Competitor number 4, echocardiography image fusion with respiratory gating. Dr. Kumar.
Hi, my name is Kumar, and what we are trying to do in this project is to extend the applicability of the echocardiography imaging. So if you look at the ultrasound, one of the limitation is its field of view. So the ultrasound, we can look at them as like a torchlight. So if you look at the beam of the torchlight, whatever we see in the torchlight, it's similar to what we see in an ultrasound. So if we want to improve the ultrasound, we have to improve its field of view, we have to improve its quality. The people go to MRI or CT because there are restrictions on this ultrasound. So our approach is to track the probe and then get where the location of the ultrasound. So this way, what we can do is we can combine multiple images. There are previous approaches which try to do a similar thing, but what they relied on is image processing. So if you look at the image processing, what we are looking, there is like a similar structure. So if we have similar structure in 2 different images, then we can align them. But what if we don't have a similar structure? What if I have put one probe in one location and the other one far, far away? Then there is no way we can align them. So in our proposed method, what we do is we also use the ECG to track the ultrasound. We also track the breathing pattern, and we also track the position of the person. So we attach markers on the person, so if the person moves during the scan, then we can track it. If we don't track that one, then what would happen is we may end up not combining these images. So when it comes to innovation, our method offers, we don't need an image overlap. We can track the respiration, so we can make sure that the person is holding the breath during the scan. And also, we do not need a computationally expensive algorithms to align these images. So that is one of the limitations if we use the existing methods. If we want to scan, we would like to see the result right away or at least in few minutes. So our target market is, if you look at the echocardiography manufacturers, there is GE Healthcare, all the big players are Siemens, Philips, they all produce ultrasound scanners. However, they don't provide a way to fuse these ultrasounds together. And if you look at our competition, there is not much. There is one company, it's a spin-off from University of Oxford, which is called Intelligent Ultrasound, which relies on image registration. So the image registration approach is what I think prevented applying ultrasound in clinical practice when it comes to multiview fusion. So we can actually overcome this limitation by introducing the trackers to the ultrasound. Thank you.
Thank you. Can we leave the last slide up? His last slide?
All right, questions?
So I have a question to start. We're talking about diffusion of something that can absolutely help patient care. You've developed something independently of the big device manufacturers. Why not just post this IP online like Tesla did?
Sorry, can you repeat that, please?
Post the IP online like Tesla with electric cars so that it gets diffused as quickly as possible. Like if you're looking at a traditional channel of bringing this algorithm, this way of doing things into the marketplace, you're doing this because you're expecting to take a traditional startup position as opposed to just disseminating the social innovation quickly?
Actually, I'm coming from an educational institution, so we would like to develop this technology so that we can make the ultrasound, we can make the applicability of the ultrasound to a wider audience. So it's more of a personal passion to make the healthcare available to most people.
So you're going with the freemium model?
Yeah, we would love to do that.
Okay.
But depending on, I can't make the decision on my own.
Okay, good poke. I want to see when the audience is paying attention. Questions? The obvious thing to do, of course, is to repeat what Calgary Scientific did.
Is the product, is it just software or is it a hardware software thing that you'd be selling?
It's actually a combination of the hardware and software. So what we do is we use the commercially available ultrasound scanners, but we have to attach a tracker to it. So currently we are using an optical tracker. There's an option to have an electromagnetic tracker as well. So that will go on top the scanner. So it's actually a tiny scanner. We can even put it inside a surgical needle. So that's a small attachment, and we can actually have a wire connection to our device. So that's a hardware component. And there's a software component as well. The software component will do the transformation, alignment, and the rest of the processing. But that can be part of the workstation. So in a clinical practice, what usually happens is we will scan the images, and then we will send it to a server or workstation where we will analyze these images. So the software can be part of that workstation where the radiologist can, instead of using the image registration approaches, they can use our algorithm to see the images.
One more question? All right, far side.
Hi, Barry Bayless. How is this different from three-dimensional echocardiography?
Oh, sorry, if I haven't mentioned that earlier, what we use is actually a three-dimensional echocardiography images. So what we get in one of these scans is actually three-dimension. But how do we handle if we have multiple three-dimensional images? So that's what we are looking at here. So I will have a three-dimensional images from one location, and I'll have another three-dimensional image from another location. And this method will allow me to combine these two together and have a three-dimensional image, but which has a better field of view.
Okay, thank you very much.
Thank you.
Thank you.